Hi, today is 18th July 2020 and from today exactly 132 days are remaining for CAT 2020, and in today's session I am going to discuss three questions from number system. So you all can pause the video and try to solve all the three questions. Okay, now this is the first question which is in front of your screen. It says this algebraic expression is nothing but it is a prime number. Then what is the sum of all possible values of n here? Now let's say if I say this is an integer. So can I rewrite this expression, that is n raised to power 4 minus n square, and then minus 2n cube plus 2n plus 2, and this number must be a prime number. Now this part, it is always an even number, as it is the sum of the last three terms, all of them are multiple of 2, so it must be even number. Now from here, if you take out n square common, or even if you do not take out n square common, that is fine. There are two possibilities. N is either odd or n is an even number. So let's say if I say n is odd, so odd number raised to power 4, that is going to be odd, and odd square, that is also going to be odd here. And the difference of two odd number is nothing but that is even, and this part is already even. So even plus even, the final result is nothing but that is an even number. Now if I say, let's say n is an even number, then n raised to power 4 is also even, n square is also even, and the difference of these two even number is also even, and the sum of the last three term is also an even number. So in that case also, the final result, even plus even, is nothing but that is even. So no matter what is n, whether n is an odd number or n is an even number, this algebraic expression is always an even number. And we also know that this algebraic expression is nothing but it is an even number, as well as it is a prime number also. So can you guys tell me how many numbers are there which are even as well as prime? Exactly one number, and that number equal to 2 itself. So it means that n raised to power 4 minus 2n cube minus n square plus 2n plus 2, this must be equal to 2. Why? Because we have already proved that this is an even number, and we already know that it is a prime, and there is only one number which is even as well as prime. Now solve this. So this 2 and 2 will get cancelled. So I'll say n raised to power 4 minus 2n cube minus n square plus 2n equal to 0. And the question is sum of all the possible values of n. Okay, sum of all the possible values of n, where n is integer. So now n is nothing but the root of this equation, and if n is the root of this equation and I need to find out sum of all the possible values of n, means what? Sum of all the roots. So what is the sum of roots? I can say sum of all the roots is nothing but that is always equal to minus b by a. So minus b is equal to minus 2 and a is equal to 1. So I'll get that is 2. So sum of all the possible values of n equal to 2. Or if you can use this formula, or we can also simplify this equation. How we can simplify? Take n as common. So if you take n as common, then I can say n cube minus 2n square minus n plus 2 is equal to 0. Now this is a cubic equation, and whenever you are trying to solve a cubic equation, always remember one thing: if the roots of this cubic equation is an integer, okay, if the roots of this cubic equation is an integer, then it must be a factor of the constant term. Okay, so whenever you are trying to identify what are the possible roots, try with the factor of 2, and the factor of 2 are nothing but plus minus 1 and plus minus 2. So you can check whether plus 1 is satisfying or not, or minus 1 is satisfying or not, or which all values are satisfying, and you can find out the roots here. Okay, so for example, we know if I put n equal to 1, what will I get? I'll get 1 cube minus, sorry, n equal to 1, so 1 into 1 cube minus 2 into 1 square minus 1 plus 2. Is it equal to 0? Yes. If you solve this, this expression is equal to 0. It means one of the root is n equal to 1. Similarly, n equal to minus 1 will also be the root, as well as n equal to plus 2 is also the root. And n equal to 0 is also root. So the four roots are here, that is 0, 1, -1 and 2. So these are the four roots, and if you find out what is the sum of these four roots, that will be equal to nothing but that is 2. So the answer is 2 here. So I hope that it is clear to all of you. Now let's move to the next question. It says, how many rational number can be written in the form of a by b such that a and b are relatively prime positive integers and the product of a and b is 25 factorial. So we know that a into b is equal to 25 factorial. And a and b are co-prime, relatively pro-prime. So a and b are co-prime to each other. So a and b are nothing but they are co-prime to each other here. So always remember one thing, if n is equal to p1 raised to power a into p2 raised to power b into p3 raised to power c and so on, then the number of ways to write n as product of two co-primes number, or we can say relatively prime or mutually prime two co-prime, is always equal to 2 raised to power k, where k is nothing but number of distinct prime factors. Okay, it is independent of the power. Like if I say there is a number n which is equal to 2 into 3. So in how many ways this number can be written as a product of two numbers such that both the numbers are co-prime to each other? This is 6. So there will be 4 ways. 1 into 6, 6 into 1, okay, 2 into 3 and 3 into 2. They are in ordered pair. Okay, they are in ordered pair. That is very important. If it is unordered, divide by 2. So that is, there are two prime numbers. So that's why the answer is 2 square 4. Even if I say, let's say n is equal to nothing but that is 2 square into 3, which is equal to 12. So 12, 1 into 12, 12 into 1. 3 into 4 and 4 into 3. So these are the exactly 4 ways in which, now remember 12 can be written as a product of two numbers in lot of ways. Like 1 into 12, 12 into 1, I can also write down 2 into 6, 6 into 2, 3 into 4, 4 into 3 and so on. But both the numbers are co-prime. So 2 and 6 and 6 and 2 will not satisfy. So these are the only 4 numbers. How we have got? As there are two prime factors, 2 and 3, so the answer is 2 square, which is equal to 4 here. So now I need to find out a into b is equal to 25 factorial. So 25 into 24 into 23 and so on till 1. So how many prime factor are there for this number? So I need to simply count how many prime numbers are there which are less than or equal to 25. Till 25 there are 9 prime numbers. And even if you do not know, it won't take too much of time to count these 9 prime numbers. What are the prime factors? I'll get that is 2 raised to power a something. Another prime factor will be 3. Let's say 3 raised to power b. One of the prime factor is 5. And then 7 and so on. C, D and so on. So just count how many prime factors are there. So prime factors will be 2, 3, 5, 7, 11, 13, then we can say 19 and 23. Okay. So 2, 3, 5, 7, 11, 13. One more, that is 17. I left it out. So there are 9 prime factors. So if there are 9 prime factors, the answer will be 2 raised to power 9, which is equal to 512 ways. So this number can be written as product of two co-prime numbers in 512 ways. So for a by b also we will be getting 512 different possible values. Remember, like 3 by 4 and 4 by 3, these are different. So order is very, very important. So the correct answer for this question is 512. So I hope that this part is clear to all of you. Now moving ahead, let's try to solve this question. Compute the smallest positive integer with 6 distinct factors. Now we always know that if there is any number which is in the form of p1 raised to power a into p2 raised to power b into p3 raised to power c and so on. So number of factors is always equal to a plus 1 into b plus 1 into c plus 1 and so on. So 6 can be written as 6 or 6 can be written as only 2 into 3. Okay, these are the only two possible ways. So in that case, the number should be of the form any prime number raised to power 5. So any prime number raised to power 5, how many factors? I can say 5 plus 1, that is 6. Or 2 into 3, it means my number is in the form of p raised to power 1 into another prime number q square. So in that case, the number of factor will be equal to 1 plus 1 into 2 plus 1. And I'll get this is 2 into 3. So there are only two possible form of numbers. Okay, if the number has 6 factors, either it will be in the form of p raised to power 5 or it will be in the form of p raised to power 1 into q square. So I need to find out the smallest. So what is the smallest number which is in the form of p raised to power 5? Where p is a prime number, I can say 2 raised to power 5. And 2 raised to power 5 is 32. So 32 has got exactly 6 factors. Okay, but the number can be of the form p into q square. So, and p and q are prime numbers. So if I take p as equal to 3 and q equal to 2, so 3 into 2 square, that is equal to 12. And this number has got exactly 6 factors. Or if I remember p and q, since I need to find out the smallest, so take p and q as the smallest two prime numbers. So p is 3, q equal to 2. Or if I take p equal to 2 and q equal to 3, then this number will be equal to 18. But which is the smallest? 12 is the smallest number. So the answer for this question is 12. So 12 is the smallest number which has got exactly 6 distinct factors. So I hope that this question is clear to all of you. And in fact, all the 3 questions are clear. In case if there is any doubt, you can post your doubts in the comment section. Alright. So thank you. That's all for the day.